Welcome guys to this next video. Today we're going to be talking about Cartesian planes and how to plot equations. Okay, so our learning goal for this one is that you can be able to graph linear relationships on the Cartesian plane, and at the end of this you'll want to be able to graph a linear function, so that's a new term, on a Cartesian plane. Okay, so first, mathematical machines. So there's these things called functions. Okay, so let's think about what is a function. Okay, so in mathematics we have some functions, and a function is based off of a variable or more than one variable. For example, we might have a function of x. Okay, what does this mean? Well, it means we've got some mathematical machine. Okay, it is a function on x, and what happens is that we get x values and shove them in one end, and out the other end of our machine come a whole bunch of y values. Okay, or I mean, it can be x and y, it could be like x and a, doesn't really matter, but x and y is kind of what we go for at this sort of level. All right, for example, if our function machine was that the function of x is equal to 2x plus 1, means that for every set of x numbers that we feed in through here, it gets multiplied by 2, 1 gets added, and we spit out a new set of numbers here. Okay, so for example, if 5 got spat in there, 2 times 5 is 10 plus 1, it would correspond to 11 in this new set of numbers. Okay, so that's what a function does. It maps one set of numbers over onto another set of numbers. Okay, so we're going to be looking at linear functions, which is a particular subset of all the other functions. There's heaps of different shaped ones, heaps of different ones that do different stuff, but linear are the ones that we're worried about for this one. All right, key ideas. The Cartesian plane, which is something I just talked about before, is a setup like this, and it has 2 axes and 4 quadrants. So its axes, the horizontal one here, this is our x-axis, right? Okay, and the vertical one is our y-axis. Okay, now they can be, as I said before, different numbers, but x and y is what we kind of tend to use for these more basic two-dimensional planes. Okay, so obviously it goes down to negative x, and this way is negative y. All right, usually it's sort of marked out in integer lengths here, so 1, 2, 3. These would be negatives, y is positive in this direction, and y is negative in this direction. Okay, now with our quadrants, this one here is quadrant 1, 2, 3, and 4. Okay, so it's important you remember where those quadrants are and what kind of numbers are positive in each. So for example, in quadrant 1, x is positive and y is positive, right? But in quadrant 2, x is negative and y is still positive. Okay, so you'll start to get a feel for that as you plot points and get more comfortable and play around with the Cartesian plane a bit more. Okay, so a point's position on the Cartesian plane is described by something called an ordered pair. So that's a special term there for you. Whoops, not in red, maybe yellow. Ordered pair. So for example, if we had some point A, it's given in its x coordinate, then its y coordinate. So the point A could be, in this instance, 7, 6. Okay, now just here we're going to have a look at an example of what that might kind of look like. So we're going to place the following points onto a Cartesian plane, typical style question for you to do in an exam situation. So I've got y this way, x going this way. Okay, so first one, A, is 3, 5. So that means we come out to where x is 3 and y is 5. So that's that, and we've got there's negative 5 and negative 5 down this end. Okay, I might just go down to negative 3. Negative 3. All right, so A is going to be where x is 3 here, and y is 5. So we come there, and there is what actually I like to do. Little crosses is probably best. So there is A. Okay, B is negative 2 and 4. So x is negative 2, y is 4. There's B. C is x is 5, y is negative 3 this time. So x is 5 go down to where y is negative 3. That's C. And D is x is negative 4, y is negative 1. And there is D. Okay, so that's how we plot points onto a Cartesian plane. Think about where the x coordinate is, where the y coordinate is, sort of trace those out, and where they meet, that's where your point is going to be. Okay? Right, let's have a look at some more. Okay, so we have these things called linear functions. Okay, and they will produce a straight line, well, hence why they're called linear functions, when they're plotted onto a Cartesian plane. Now, linear functions have a basic form, which is this. This is something pretty important. You should get used to this. Very important, okay? So, because this sort of comes up all the time, all right? Later on, you'll learn that this M is something special to do with the graph, and so is the C. Not important in grade 8 level, but it is something that we'll probably end up talking about, okay? So the variables in this situation, so Y is a variable and X is a variable, whereas M and C are constant numbers, okay? All right, there's a process for us to go through when we are plotting a linear function. So that is, first we create a table of values, okay? It's one of those things where you sort of have a little table like this, have an x and y, you feed in some x values, and you put your y corresponding y values down there. Well, there was an example later on if we'd have a look at what that sort of looks like. Then you substitute each x value into the function to get the corresponding y value. Because remember, our coordinate for a point is an ordered pair. So it's got an x part and a y part. All right, they go together. Then you plot your ordered pairs onto the Cartesian plane and draw a straight line through the points. All right, let's have a look at an example of what this looks like. Let me just move my axis out here a bit. There we go. All right. So we've got construct a table and draw the graph for the function y equals half x plus 2. Okay, now let's just draw a little bit more stuff here. So this is my y-axis and my x-axis. Okay, and 1, 2, 3, 4, 5. That's positive 5, positive 5, negative 5. Okay, now, and where's my negative 5? 1, 2, 3, 2, 2, all the way down the end. Okay, so construct a table, draw the graph for the function. So we've got our table here already. So see how it's got an x row and a y row, and I've filled up the x with all these values. Okay, now you don't have to do so many values, because to draw a line, you only need 2 points, where it starts and where it finishes. Okay, but just to sort of show you how this works, and I want to just go through the whole process to show you exactly what happens, so that you sort of not really skipping over steps at this stage. Okay, so negative 3, we're putting that into our function. So I'll just show you an example with negative 3. So we'll have y is equal to half of negative 3 plus 2. Negative 1.5 plus 2 is 0.5. Okay, so this one's 0.5. So when x is negative 2, so that would be y's half of negative 2 is negative 1, plus 2 is 1. Half of negative 1 is negative 0.5, plus 2 is 1.5. Okay, 0, half of 0 is 0, plus 2 is 2. Now you're probably noticing something here. They're all going up by a consistent amount. That's to do with this slope value here in front of it, the multiplier of the x variable. Half of 1 is 0.5 plus 2 is 2.5. This one will be 3, and this one will be 3.5. Okay, so when we plot these, really we only need to plot 2, but I'll show you 3. So we'll plot this one here, this one here, and this one here. So x is negative 3, which is here, whoops, here, negative 3. Y is 0.5, so that would be here. So here's our first point there. Okay, x is 0, y is 2. So x is 0 is on the y-axis, okay, because there's our origin there. Oh, which I should have said before. This is called the origin. Okay, 0, 0. All right. So the point where the axis cross is called the origin. What have we got? 0 and 2, then 3 and 3.5. So here. And you'll see that that creates a nice line if we draw through it, hence why it is called a linear equation. Okay? Right. Again, with a lot of this algebra stuff, the number one thing you can do is practice, practice, practice. Plenty of examples for you to have a look at in your exercises. And I hope you enjoyed the video. Please come and chat to me if there's anything you didn't quite get. And I'll see you at school. Bye.